Hello everyone, welcome back to my YouTube channel. My name is Rakshita S. I am currently pursuing third semester Computer Science Engineering in Sri Venkateshwara College of Engineering, Bengaluru. I belong to the Department of Computer Science and Engineering from the section of Chanakya. Today's course title is Operating System and the code BCS 303. And the today's topic is a study on unmanned aerial vehicles operating system security future research challenges. Let's look at into the content. So, firstly, we discuss about the introductions on unmanned aerial vehicles, which is followed by the background of unmanned aerial vehicles and the common UAV operating system and the security measures, and a survey on common UAV security issues and the possible solutions. And then we have a future research challenges. At last, we have the conclusion. So, let's discuss briefly about the one by one. So, firstly, we have the introduction on unmanned aerial vehicles. So, unmanned aerial vehicles, which it is defined as a space traveling vehicle that can fly without a human crew on a board and that can be remotely controlled or can fly autonomously. So, recently, that unmanned aerial vehicles or drones have become an area of intense interest as they can be used for many military and civilian applications including as follows the military attacks, the state intelligence and surveillance, and the board security and the communications relay, agriculture and remote sensing. In addition, the UAVs effectively revaluation many a business and creating a new opportunities. The business and creating new opportunities, the drone stands for the dynamic remotely operated navigation equipment. So, it flights is either controlled autonomously by the computers or under the remote control of a pilot on the ground. So the second one we have the background of UAV. Let us discuss. So modern UAVs debuted as an important weapon systems in the early 1980s when the Israeli Defense Force fitted small drones resembling a large model airplanes with a trainable television. So infrared cameras and with the targeted designators for laser guided munitions all downlinked to control the stations. So Regist Astin 10, which defines a UAVs as system comprising a number of subsystems including the aircraft, often referred to as a UAV or a drone. So its payloads like the weight of a UAV can carry, and the ground control station we call it as GCS, and the communication subsystems. These are all which including under the background of UAV. So the next one we have a common UAV operating system and the security measures. So first in this we have the information and software security. Let us discuss. It includes the collected data, the flight operation data and mission related data, configuration files. So these issues matter the most where the drone is a part of a military government. So if captured by an enemy agent, the operating systems need to make sure that the data connected cannot be compromised. So even for consumer drones, there are cases where the official drone firmware was the jailbroken and users were able to bypass no-fly zones. So the second one, we have a sensor security. So accelerometer, uh, gyroscope, magnetometer, borometer, GPS, and camera that are crucial for the real-time maneuvering. As a result, the operating systems needs to have a protective measures to different kinds of sensor based attack as there is no humans to verify the inputs. The third we have the communication security. So the UAVs communicate mainly with their ground control stations, and the information exchanged between a UAV and the GCS include the commands to control the UAV, telemetry feeds, and non-critical payload data. So, since these communications happen using different wireless communication techniques, example like Wi-Fi, Bluetooth, LTE, and Zigbee. So, jamming and spoofing attacks are possible, similar to the sensor attacks described above. So, the jamming is the most popular denial of services, which is called as DOS, attack that can be performed against a radio links. So these are some the common issues like anti-drone system and used a directional antenna to generate a high power. So the jamming signal in order to disconnect a drone from its control. The efficiency of commercial LTE signal jammers against LTE based drones. They conclude that the jamming is efficient for short range distance of approx 60 meters relevant for household residences, protecting against the data breaches and identify theft to ensure that what we want to say is not twisted by the other person and to avoid the damage it can do in case of a leak. So the other measures to address the threat of UAVs, which includes like a drone rules that demarcate who can operate drones and no-fly zones, like a collaboration between law enforcement agencies and digital sky platforms that requires drone operators to obtain necessary permission and the approvals, and drone detect deter and destroy system, D4S, we call D4S, which means a drone detect, deter and destroy system that can detect rogue drones and jam micro drones. You can observe the pictures here. The first one, which is called as a home, which control the safe, which protect the safe against the ohms. And the next we have a survey on a common UAV security issues and possible solutions. Security issues of UAVs. Security issues associated with UAVs in the national aerospace greatly increase the likelihood of performing a passive and active attacks in this section. First one, the sensor level. UAVs rely on sensors to gather data about the surrounding environment. These data are sensitive and need to be protected from malicious actors. And the hardware level, the adversaries considered UAVs as a potential means to conduct a physical attacks in the national aerospace. The software level. Having discussed the hardware level issues, we introduce the software level issues by presenting the vulnerabilities, threats, and attacks targeting the software level of UAVs. And the last, the communication level. Communication level is the critical component of the UAV system to flight control and data transmission. And we have the common issues with unmanned aerial vehicles. Despite their potential, UAVs face several challenges, like a battery life is a crucial limitation, hindering a prolonged flight durations. UAVs can also be susceptible to interference from the electronic signals, impacting the performance, the reliability of GPS in challenging environment like dense forests or urban canyons can be issue. So what are the common issues we have is the battery life and the limited flight light restricts their use for longer machines, and the signal interference. External signals can disrupt the communication and control. GPS reliability, signal loss in a complex environment hinders accurate navigation, and the safety concerns. Safety protocols need to be robust the prevent accidents. The technological solutions for UAV issues. So what are the possible solution we can do is the like a battery technology we have, and the higher energy density batteries and efficient power management systems are extending flight time. Communication protocols improve the communication networks and secure data and encryption enhance reliability and resilience. Navigation and autonomy, advanced sensor and AI powered algorithms are enabling autonomous flights and obstacle avoidance. the challenges in unmanned aerial vehicles operating systems. So the aerospace management we have, and the balancing UAV flight with the traditional aircraft operations we have, and the requiring robust aerospace management strategies to ensure safety and efficiency, regulatory compliance, navigating the complex, including licensing, aerospace authorizations and data privacy, safety concerns, and the public precision and privacy violation, noise pollution, and potential misuse through effective communication and transparency. The last we have a conclusion. So UAVs are one of the modern technological marvels that will soon revolutionize different industries. They will be used for delivering of food and merchandise, enforcing parking regulations, performing surveillance, etc. So, over the next 16 years, the drone will become a significant component of military, civil, perhaps even a commercial aviation. However, the very dynamic nature of the field also create a significant amount of uncertainty. The wide range of drone physical and performance characteristics, many of which will be a very unlike any current aircraft, will place additional challenges on air traffic management system. So thank you for listening.